Okay, our group, our common theme is that we all teach classes where the students have a difficult time connecting the concepts that we teach with things that are actually important, or at least they perceive as important. And so we're really trying to bridge that gap between fundamental concepts and real-world applications. So our short pitch is that our observation is low student motivation and that we have low student motivation in our classes and loss of students from the curriculum. And we think that the problem is that engineering education has really lost that connection between the real world and the concepts that we're trying to teach. And so the solution is to implement really tools that everybody can use in their classrooms to bridge that gap, and my colleagues will help explain what we mean. We have a little cartoon down here from Calvin and Hobbes to illustrate, where the dad is perhaps the lazy student in class that thinks everything is magic, and the mom, the voice of reason, instead of saying that's not magic, really she should be saying that's engineering. So.
Okay, so we start to look at intrinsic motivation. So when I talk to colleagues and we start talking about why we have all this great material that we have to present, why can't they even show up? You see? So I think at some point we have to say maybe it's the way we present the information, or maybe if we change the classroom experience, because we're talking about a lecture before an exam when the students know that we might give them some pointers about what will be on the test. They just don't show up. So at that point, it's about how to motivate them. And the result of that is we're losing, they come to engineering and then we're losing a lot at some point. They go into different majors. And again, doing meetings, we may say it's because the course is too difficult or the low retention of information. One of the excuses that I hear is that, well, it's not the department, it's the math, the physics, it's some other department where they have to take some courses. But it's getting to a point, even the courses that we offer, they're not doing well. So if they go to a different class, of course they're not gonna do well. Even within the same course, information that they would need from a previous chapter, they're not able to apply that. So we start to look at some ways to, at least reverse the trend, and my colleague will be happy to talk about that.
Sure. So this issue of loss of motivation is something that we've all seen, and our guess as to what might be happening here and how we might be able to address this is to look at what may be the root cause, which is the loss of real-world applications in engineering education. And most of us, I think, and most students that come into our classes, they've come not because they want to solve a bunch of nonlinear differential equations, right? That's not their point. That's the value of death, I think, that we heard mentioned earlier, right? They come because they want to solve problems, human problems, and they want to see a connection to what they're doing now to, how does this thing at my house work, or how is this going to fit into my job? So they do have this low interest in these foundational classes, but yet if they don't succeed in these classes and they don't make these really important connections, they actually can't execute in the senior design course and they can't execute in careers. So how do we make this connection between what they're doing now with what they need to do in the future?
So we talked about several possible ways that we could start trying to integrate industry or real-world solutions into our classes, and a couple of the ideas we tossed around first were, bringing professionals or actual real-world, engineers into our classroom, actually taking our students on field trips to companies. That's a little bit more complicated, or perhaps doing teleconferencing with engineers along, in parallel with our classes. And I've actually tried all three of these, and none of them really worked for a variety of reasons, but yeah, we can go into that in more detail. So, speaking from experience, an alternative is to bring the real world into the classroom, perhaps in a more controlled manner, by essentially having not scripted, but kind of modularized questions that you get the industry members to pose, and then you can basically use that to kind of prompt and motivate whatever class you're going to have. Now, the challenges with doing this is you need to make sure that the questions that your industry colleagues are posing are actually at an appropriate level, right? You want to make sure that they aren't posing a question for your thermo class that is more appropriate for a grad level. And it also needs to provide context for whatever your class is going to be, and it needs to be concrete. And your engineers also need to be friendly and accessible, right? Because you want your students to stay in the class, not run away. But my colleague's going to give more detail on how we're actually going to do this and source select our engineers.
So one example of how this could be implemented, for example, in your structured lecture format, is that instead of starting by deriving your favorite constitutive equation, you would start by having this introductory video question from a practicing engineer that's being pulled from the repository that we'd be developing. And class would be then broken down into 15-minute increments, where you'd start with the question, then provide a demo or hands-on activity that would be together in the module, give some information as part of a lecture, and then go back and provide a small groups an example problem to be worked in class, or depending on your class time, to be worked outside of class and brought in back. And then the question is, does this example then reinforce the concept in the video, or how did your example problem differ from what happened in the demo? And so these modules would be tailored to the student level, where you'd have modules that would be appropriate for freshmen prior to taking a class, for students that are in a class divided by the different topics being taught in that class, and then higher level modules for students who had potentially taken already that class, but you wanted them to think on a higher level about something that they needed to remember from a prior class.
Okay, finally, we discussed about the collaborations and sustainability. We believe those are the common issues for foundational classes. So we think shared resources through, for example, online repository could be a good way to carry out the project. And to facilitate collaboration and also for the consideration of sustainability, we think we need to invest in easy, accessible, and searchable archive, and also we need to provide structure to facilitate broad participation. Also, the site will have ability for individuals to add demos or activities, and also the modules will be moderated. And also, we believe there are some synergistic benefits from collaborations. For example, each one will have access to a wide range of industrial sectors. Also, we believe there's synergy between those teaching lab classes and lectures. Thank you. Question?
Yeah, so what would be your approach to making sure you get a diverse group of industry people in that repository?
That one's mine, apparently. So at least in my experience, what I was planning on doing is basically selecting from my friends. And I'm fortunate in that I'm female, and most of my friends are female. So by default, there's going to be a heavy emphasis, at least from my colleagues, there's going to be a lot of female engineers. And then I have a feeling Megan has a lot of female engineers as well.
Yeah, there's different kinds of diversity as well, I guess,
Yes.
right? There's sort of ethnic and gender diversity, but then there's also diversity of different types of fields. And we actually thought that this repository approach could help in that, right? So if locally in Southern California we have an excess of biomed, but not many, whatever, petroleum or agriculture or whatever, we have a lot of that too, I guess. But
Yeah.
if there was a place where there was a lacking in one industry, you wouldn't have local connections, this repository could help with that. So we think it should actually improve diversity.
But I'd also say that could be one advantage of our specific teaming,
Sure.
is that we have both geographic, ethnic, gender, everything. We're awesome. We're awesome. I'll stop there. very humble.
Hi, I'm Ines Basalo from the University of Miami. I just wanted to share what I've done in my materials science course for this. I use YouTube a lot for videos. So I want to give you an example. We were discussing fatigue and fatigue testing. And Boeing has some really cool videos online of a fatigue testing of a 787. So it shows, all the sensors connected to the frame, engineers talking about what they do and why they do it. Mm-hmm. And these are, 5 or 6 minute videos, and they're there online available. So just wanted to share that.
I was pointing there because he had, but yeah.
Sorry, and we're unmiked up here, so I'll try this, unless I have to be mic'd for that. I'm trying to integrate in a long time constant. So our group and lots of other groups and the amazing art presentation that we just had, something strange has happened. Let me just throw that out there. Why is this so hard for us to take all of the human condition, be it artistic, be it diverse, be it women, be it global? Why is it so hard for us to wrap our heads around we're all building to improve the human condition? And Dan mentioned at the kickoff yesterday, 25% of NAE members don't have the word engineering on their CVs. And this is really hard for us. And I really have no clue is the shortest answer. And I just thought of something that might be problematic, which is, I was just trying to, again, think on a long time constant. Why is it so troubling for us to put arts and engineering in the same context? And I think it's our and our institutions and our academia's fault. We have such strong identities with the classes we teach and the clubs we hang out in. And I love NAE, but the rooms we hang out in. And there's this notion that we need to divide to build. And how on earth have we gotten ABED to wag art apartment's tail? That whole system is weird. So I have a friend who wrote the dictionary. Her name is Erin McKean. If you've seen her TED Talk, great. If not, please look it up. She brands for a living and knows all of the words everywhere because she wrote the Oxford Dictionary. I think we need a better word. There's something about the arts and engineering and all of these fields that's the exact same thing, but we've broken it all up because of academia. And there must be a way, there must be a language and a connotation by which we can put this back together again. And to me, it just seems weird that this is so struggleful.
Well, I'm not sure I can address all your points. I'll try anyway. I think you're talking about what we look at as a proof of life. A lot of times, instructors do not want to teach something that they don't feel comfortable with. They don't want to go in that area. So they take problems and they reduce it to what they know. And sometimes it would be nice to go to a colleague, an expert in thermodynamics, for instance, or physics, and say, well, I really don't have a way to present. Could you help? But again, we have the ego that gets in the way, and we just don't want to lose face in front of the class. And even a simple example, to bring someone, I was associate director of the pharmaceutical engineering. Even when I teach graduate class, I would have people from the industry, and I really have to make it clear to the student that, well, this person is there to teach you the industrial aspect, the application, because it's very easy for them to believe that it's because I do not know what I present. That's why I have somebody to reinforce what I'm saying. So it's really it asks for a paradigm change, and also be comfortable with yourself, with what you know. If you don't know it, well, I don't know that. I need somebody else. And it's also, you're talking about open-ended lab. One of the reasons people don't want to do that is it's possible the student come up with a solution and they say, do you want this? Like, well, I have no idea what you have just done. Give me some time. People don't want to go there.